Good morning, everyone. Now we have section 12.3, exponential function. An exponential function with base b is defined by the equation y equal b to the power x. B here is constant. B is constant, so b not equal to 1 and b greater than 0. X is a real number. The domain for this function is set of all real numbers. So the domain is minus infinity to infinity. Let us graph this function. So let us take this function y equal 5 to the power x. So here this function is exponential. Here b is 5. So 5 is not equal to 1 and greater than 0. So let us take x any value. Let us take two values negative, two values positive with 0. So here we have negative 2, negative 1, 0, 1, and 2. So to find y, so substitute negative 2 for x in this function. So we get 5 to the negative 2. 5 to the negative 2, use the properties of negative exponent. So this is equal to 1 over 5 squared, or 1 over 25, which is equal to 400. Similarly, if x equal negative 1, so now substitute negative 1 for each x here. So we get 5 to the negative 1, which is equal to 1/5. 1/5 is equal to 2000. If x equals 0, so 5 to the power 0 is 1. If x equal 1, 5 to the power 1 equal 5, and so on. 5 squared equal 25. Now to graph these ordered pairs, so here we have negative 2, 400. So we start from the origin, move 2 units to the left, then 0.04. So this one is close to 0. So let us say this point is negative 2, 400. Then negative 1, 2000. So from the origin we move 1 units to the left, then 2000. So this point is negative 1, 2000, and so on. 0, 1, 1, 5. So now graph a smooth curve passing through these points, so we get this curve. If you look at this function passing through 0, 1 and 1, 5. So in general, the exponential function passing through 0, 1 and 1, 5. 1, 5 here is what? 5 is b. So passing through 0, 1 and 1b. In this example, b equal 5. In this example, b here is 5. Also, the x-axis is the asymptote. Never intersect this this function. Never intersect the x-axis. So the x-axis here is the asymptote. If you look at this function, the range, the values for y is greater than 0. So here y takes 0 greater than 0. So here this is the values for y. Look, there is nothing negative or 0. It is greater than 0, less than infinity. So the range here is greater than 0, less than infinity. This function is increasing. Increasing means when x increase, y is also increased. So look at x. X is increased. Negative 2, negative 1, 0, 1, 2. Y is also increased. So 400 then becomes 2000, then 1, 5, and 25. So this is the properties of exponential function. Now let us take another example. So let us take if b equal 1/5, or if b between 0 and 1. Excuse me. If b is between 0 and 1. So let us take b 1/5. So let us graph this function also. So here if x equal -2, so 1/5 to -2 by the properties of negative exponents. So flip this fraction, so we get 5 over 1, then change negative to positive. So we have 5 over 1. So 5 over 1 square means 5 square over 1 square. So each factor is raised to the power 2. 5 square is 21, over 1 is 5 square is 25, over 1 equal 25. If x equal -1, so 1/5 to -1 equal, flip this fraction, 5 over 1, then change negative to positive. 5 over 1 is 5. 1/5 to the power 0, any number to power 0 equal 1. Then when x equal 1, 1/5 to the power 1 equal 1/5, which is equal to 2000. If x equal to 1/5 square equal 1 square over 5 square, which is equal to 1 over 25, and this is equal to 400. So if we graph this function, we get a smooth curve like this. This curve never intersects x-axis, so the x-axis is the asymptote. Also this a function passing through 0, 1, look here, 0, 1, and 1b passing through 0, 1, 1b. In this example, b equal what? 1/5. So this point is 1 1/5, 1 1/5, or 1 2000. The function is decreasing. Why? So here, when x increased, y is decreased. So 25 becomes 5, then 1, then 1/5, and so on. So if b between 0 and 1, if b between 0 and 1, the graph y equal b to the power x is a decreasing function. While if b greater than 1, in the first example b equal 5, 5 is greater than 1, the graph is an increasing function. Now here we have the properties of exponential function. The domain of the exponential is the interval minus infinity to infinity. The range is the interval 0 to infinity. The graph has a y-intercept of 0, 1, or passing through 0, 1. The x-axis is an asymptote of the graph, so the graph never intersects x-axis. The graph passes through the point 1b. So if b is 5, so passing through 1, 5. If b is equal 1/5, so passing through 1 and 1/5. If b greater than 1, then the exponential function is an increasing. While if b between 0 and 1, then the graph is a decreasing function. Also, the exponential function defined by f of x equal b to the power x, where b not equal to 1, b greater than 0, is a 1-to-1 function. So let us prove that this function is 1-to-1. So we know that the domain for the exponential is minus infinity to infinity. The definition of 1-to-1 is what? Take any two different values in the domain. So for example, take 2 and 4. 2 and 4 belong to the domain of this function. Now, 2 is not equal to 4. such that here 2 not equal to 4. So this is two different input values in the domain. If we get two different values y in the range, so we say that this function is 1 to 1. Now substitute 2 for x in this function, so we get b to the power 2. If x equal 4, we get b to the power 4. It is clear that b squared not equal to b to the power 4. Therefore, this function is 1 to 1. So here, to verify that, or to prove that the function is 1 to 1, so here we take any two different values in the domain. So suppose x1 and x2 belong to the domain, such that x1 not equal x2. If we get b to the power x1 not equal to b to the power x2, we say that the function is 1 to 1. So here we take two different values in the domain, and we get two different values y in the range. So we say that this function is 1 to 1. Graph a translation of an exponential function. So now let us graph on one set of axes, graph these two functions, which is exponential, 3 to the power x and f of x equal 3 to the power x minus 2. So now let us graph these two functions by using the properties of exponential functions. So first, to graph this function, f of x equal 3 to the power x. So here b equal 3, and 3 is greater than 1. So since b greater than 1, so the graph is increasing. If b greater than 1, then the function or the exponential function is increasing. Also, the exponential function passing through 0, 1 and 1b. In this example, b is 3. So passing through 0, 1 and 1, 3. So now we can graph. X-axis is the asymptote, so never intersect the x-axis. So now let us graph these two functions according to these properties. So passing through 0, 1, this point is 0, 1, and this point is 1, 3. Now graph a smooth curve passing through these 2 points. So the graph here is increasing. When x increased, y is also increased. So look here, x 0, 1, 0, x is increased, y is also increased. So this is the graph for f of x equal 3 to the power x. Now to graph this one, f of x equal 3 to the power x minus 2, so this is vertical translation. So just we shift this graph 2 units down. Shift this graph 2 units down. So this means this point, shift this point 2 units down, 1, 2. Shift this point 2 units down, so 1, 2. Then graph a smooth curve passing through these 2 points. So this is the graph for f of x equal 3 to the power x minus 2. Let us take another example if the translation is horizontal. On one set of axes, graph f of x equal 3 to the power x and f of x equal 3 to the power x minus 2. So here we have a horizontal shifting. Now from the first example, the graph for f of x equal 3 of x, it is the same, this one, it is the same, passing through 0, 1 and 1, 3. This is the graph for f of x equal 3 to the power x. Now to graph this one, f of x equal 3 to the power x minus 2. So this is horizontal shifting. If here, if we have negative negative 2, we move to the right 2 units. If we have positive, we move to the left. So here we have negative, so we move to the right 2 units. So this means this point, which is 0, 1, shift this point to the right 2 units, 1, 2. Also shift this point to the right 2 units, 1, 2.